So we want to take a look at parts of a 3D object. So when we're looking at a 3D object, we want to be able to pull out certain parts, and we also want to be able to refer to the object using appropriate vocabulary. So each segment in this object, so I'll highlight a segment here, is what we refer to as an edge. All 6 sides of the cube, so this is a cube, is referred to as a face. Maybe we'll do that in a different color so we can highlight it on there. So this is a face. So if I was to color in a face, it would be like the front face of this cube. Intersections of our edges, so like this point right here, these are called vertices if we have multiple of them, so that's the plural. Or if we only have one, it's called a vertex. Okay. So we want to take a look at this figure and pull out some different pieces of information about it. So it asks us how many segments are in the figure. So we're going to go through and we're just going to count them. So that's essentially asking us how many edges are in the figure, right? So we have 1, 2, 3, 4 on kind of the top of the figure, 5, 6, 7, 8 as our sort of what makes up the vertical part of our figure, and then 9, 10, 11, 12 on that bottom of the figure. So we have a total of 12 faces. Okay, so now it asks us to name all segments that are parallel to segment EF. So let's go ahead and highlight EF on here. We want everything that's parallel to EF. So that means everything that's on the same plane. So the two easiest ones to see are segment GH, right? Because they share that bottom face. So GH. And segment AB, because they share kind of that back face there. The one that's hard to see is one that makes up an invisible plane. And it's this plane right here, this sort of diagonal plane that's through the figure with CD. All right, so when you think about parallel, I like to think of it as if I'm wrapping my way around the figure to get back to my start. What did I go through to do that? That kind of helps us see what segments are parallel to that original segment. Okay, name a plane that is parallel to plane DHG. So the way we're going to identify the plane is we're just going to find those 3 points, D, H, and G. We're going to just trace between them and then continue on with the face that they were part of. So we're looking at that face right there. So we can't have any face that intersects this. So plane and face, we are using interchangeably here, okay? So if I look, this side face here intersects that, so this plane right here intersects that front face, right? They share CG. This bottom face, it shares GH. The kind of right face, if we trace that, it shares DH, but the back face of this, they don't share any segments on the figure. So that would be our parallel plane. So our parallel plane, we can name it plane, don't forget to use that word, and then pick any 3 points. So B, F, E are the 3 that I'm going to pick. Okay, so now let's take a look at naming skew lines. So if we're thinking about skew, we looked at this as lines that are not intersecting but also not on the same plane. So when we think of skew lines in a figure, we want to think not intersecting, don't quite have enough space there, not intersecting, and not parallel. Okay, because remember, skew and parallel are different. So if it's parallel, if two lines are or segments are parallel, they're not skew. So this is the easiest way to identify our skew lines, is to first identify things that are intersecting that line and things that are parallel, and then everything left over is skew. So let's go ahead and do this. So our skew line is FH. So this is FH. We want everything that's skew to this. So first we're going to start by eliminating. We're going to eliminate any segment that intersects that. So the first segment that intersects it is HD, HG, FB, and FE, right? Anything that shares an endpoint, essentially. The next thing we're going to do is eliminate anything parallel. So again, think about wrapping around the figure. So we're going to wrap around the figure, and any segment that we hit when we wrap around is parallel. So EG, AC, and BD are all parallel to FH. Now, everything that we have left over are our segments that are skew to FH. So they are neither intersecting nor parallel, which means they shouldn't be on the same plane. So those are, I know it said just name a segment, but I figured I'd show you how to find all of them. So for this, we have AE, GC, CD, and AB. We're all skew to that original segment. Okay. So now it's asking us how many faces are in this figure. How many faces are in this figure? So for that, we just kind of want to think about this like a box, right? How many faces does a box have? So we sort of have one here in the front, one on the right, one on the left. So I can actually count those. 1, 2, now we're at 3. One on the back, 4. Then we got one on the top, 5. And one on the bottom, 6. Okay, so don't forget about your kind of hidden faces, the ones that are behind the figure that we don't necessarily see. Okay. Name the intersection of EF and BF. So we can trace this on the figure if we would like. So EF and BF, and see where they intersect here. All right, here's EF. And we got to scroll up. Here's BF. And what do they share? So the only thing that they share is right here, point F. So we can say they intersect at F. Oop, I got ahead of myself. So we did letter G before letter F here. Okay, so name the intersection of EF and BF. So we did that last question. So now let's jump back up. Name the intersection of planes ABC and AEG. We're going to do the same thing. We're just going to go ahead and trace them on our figure to start. So we have planes A, B, C. So A, B, C. And then we'll just go ahead and continue that top face. And then we have plane A, E, G. All right, and my two lines overlap right here. So that entire segment AC is where these two planes overlap, or those two faces. So that was A, the back up to my figure for a second. C, AC.